Okay, good day everyone. So I will be your teacher for today. But before we start our discussion, let us have a prayer. Okay, again, good day. So are you ready? So before we start our lesson, I want to ask you a question. Have you tried to answer abstract reasoning tests? Like when you had your entrance exam or NCAE, National Career Assessment examination. So for those who are not familiar with it, so I'll show you an example of abstract reasoning tests. Okay, so I'll prepare a 5-item abstract reasoning test. You're going to answer it, and then later we're going to check. So what is abstract reasoning test? Okay. An abstract reasoning test measures your ability or aptitude to reason logically. Generally, abstract reasoning test measures non-verbal abilities. You must do logical and abstract reasoning, extract rules, analogies, and structures, which you subsequently use to find the correct answer among a set of possible options. So, given a non-verbal exam or test, you're going to identify the rules of the given diagram or figures, okay, for you to come up with an answer. Okay, so given different figures, what will be the answer or what is the missing pattern? Okay, abstract reasoning tests are almost always a part of any job assessment or intelligence testing setup. So again, so when you had your entrance exam, I'm sure there is an abstract reasoning test. Okay. You can use this test as part of an IQ test training to make sure you are maximally prepared. So abstract reasoning test class are much alike to inductive reasoning. Okay, when we say inductive, it's from specific to general. And it's a diagrammatic reasoning test. So you're going to the test includes only diagrams or figures. Okay, they attempt to measure your lateral thinking and fluid intelligence with the objective of finding the accuracy and speed in which you can identify and interpret relationship between a collection of shapes and pattern. To successfully complete abstract reasoning tests, you need to be able to think creatively and use lateral thinking to solve problems. Okay, you need to see the relationship between shapes and figures. Okay, identify rules and similarities and quickly apply this to identify the answer. Okay, are you ready? So I'll prepare 5-item abstract reasoning test. But before we proceed with that, let's have a trial. Okay. By the way, class, the choices, okay, the arrangement of choices is like this one. Okay, with this. Okay, So let's have a trial first. Okay, given this pattern or this diagram, what do you think is the missing? Okay, I'll give you 5 seconds to answer. 5, 4, 3, 2, 1. Okay, I'll call one student to answer. Yes, Gwyn, what is your answer? Okay, the answer is letter D. Okay, so we're going to identify the pattern. So as you've noticed in this diagram, we have this. Okay, so obviously the answer is letter D. Okay, so are you ready? Okay, so let's start with number 2 as number 1. Okay, given this diagram, okay, those figures, what do you think is the missing? Okay, so again, this is A, B, C, and D. So what do you think is the missing? 5, 4, 3, 2, 1. Okay, next. How about this figures? What do you think is the missing figure? Okay, again, this is A, B, C, and D. 5, 4, 3, 2, 1. Okay, next, number 3. Number 3, given these figures, okay, what do you think is the missing figure here? Okay, so again, this is A, B, C, and D. Okay, 5, 4, 3, 2, 1. Okay, next. Last 2. Given this test, abstract reasoning test, what do you think is the missing? Okay, what do you think is the missing figure? Okay, A, B, C, or D? 5, 4, 3, 2, 1. Okay, the last one. Okay, given this figures, okay, identify the pattern or the rules for us to answer what is the missing figure here. Okay, again, this is A, B, C, and D. Alright, so let's try to check your answer. Okay. Wait. Okay. So again, in our trial, okay, the answer is letter D. The 9 cells in the grid make a symmetric shape. Your answer was correct. Okay. So let's start with number 2 as your number 1. Okay. The answer is letter C. The figures in the first column, okay, this is the first column, grow in size each step to the right. Going to the right, okay, it grows. So the answer is letter C, cat. Okay, we got the correct answer for number 1. Okay, very good. Most of you got the correct answer. Next, how about this? Number 2. Okay, the answer is letter B, boy. Why the answer is B? The width of the figures in the first column shrink in size each step to the right. Okay, so lumiliit. The answer here is letter B, boy. Okay, who got the correct answer? Okay, very good. Next. Number 4. The answer is letter A, apple. The figures in the first and second column are merged. When you combine the first and second column, the answer is the third column. So the missing here is the first column. Okay, the answer is letter A, apple. Okay, next, last 2. Here, number 4. Okay, the answer is letter D, dog. The figures in the first and second column are merged in the third column. So when you combine the first and the second column, the answer is the third column. So when we combine these figures, the answer is letter D, dog. This one. Okay, who got the correct answer? Okay. Very good. Next. The figures in the first and second column are merged in the third column. So we're done with this. And the last number, the black circle moves up each column. Okay. The white square moves to the right each column. Every row in placement of the white square is different. So the answer is letter C, cat. Okay. Who got the answer? Who got the correct answer for this number? Okay, very good. So who got 5? Okay, very good. 4. Okay, and 3. Okay. So lower than 3, very good. Okay, no students got lower than 3. Did you enjoy our activity? So what do you think is the relationship of abstract reasoning test in our lesson for today? Okay, so we need to identify the pattern given a set of numbers or figures. We're going to identify the rule behind it, okay, to find the missing or the next term or the next figure. Okay, so let's start with our lesson for today. Are you ready? Okay. So all of you got the correct answer. We need to identify the pattern. So our lesson for today is about sequences and series. So later we're going to define what is sequence, what is series, what is the difference between the two. So when we say the numbers in sequences are called terms. So by the way, what is a sequence? So have you tried to answer a sequence problems before? Okay, so let's have a free test, for us to identify what is a term, what do we mean by sequence, by this pretest. For numbers 1 to 3, write the first 2 terms of the sequence. So how are we going to identify the terms of the given general? This is the general formula. Given this general formula, we're going to find the first 2 terms. But how are we going to do that? Yes, 1. Okay, very good. We're going to substitute, the value of n, where n is set of counting numbers. What do we mean by counting numbers? Yes, Rain. Okay, when we say, that's correct. When we say counting numbers or natural numbers, those are numbers that starts with 1, 2, 3, 4, and so on and so forth. That's why it's called counting numbers or natural numbers. So we let n be equal to 1 for the first term, and we let n be equal to 2 for the second term, since we're asked to find the first two terms of the sequence. So let's try to answer number 1. Or who wants to try number 1? Yes, Francis. Okay. Try to answer using our typeboard. Then we're going to compare your answer with your classmate's answer. Then we will see if you have the correct answer. Okay, Francis, what is your answer? Okay, what is the first term? Okay, the first term is 4. How about the second term? Okay, the second term is 9. So we have the sequence 4 and 9. Okay, so this is the solution. Okay, we're going to substitute first 1 in n to find the first term. Okay, and the first term is 4. Okay, the second term, we're going to substitute n as 2. So 2 plus 1, it's 3. When we get the square root of 3, it's 9. So the second term is 9. Very good, Francis. Okay, did you get it? Okay, how about the second term? Yes, Laureline, what is your answer? Okay, try to answer number 2, Laureline. Yes, Laureline, what is your answer? Okay, the first term, what is your first term? Correct, it's 0. How about the second term? The answer is 7. Can you explain your answer? Okay, so this is the solution. Laureline's answer is correct, 0 and 7. Okay, 0 and 7, class. Okay, for the second example is an example of term. Okay, 0 is the first term, 7 is the second term. Okay, so let's go back to our discussion again. Okay. So the numbers in sequences are called terms. So in number 1, our answer is, what is our answer in the previous? Yes, that's correct. For number 2, we have the sequence. Okay, 0 and 7. 0 and 7, we call them terms. Okay? You can think of a sequence as a function whose domain is a set of consecutive integers. If a domain is not specified, it is understood that the domain starts with 1. Like in our pretest, okay? We start with 1. Okay? We let n be the set of what? Set of counting numbers or natural numbers. We start with n is 1, n is 2, okay, and so on and so forth. When we say domain class, it's the set of x values, or those are the inputs. Okay, these are the values okay, for x. These are the values of x, okay? So those are the inputs. So like in our example, we let n be equal to 1, n is 2, n is 3, n is 4, and n is 5. The domain gives the relative position of each term. When we substitute n to the given formula or general rule, we're going to have an output, which is 3. When we substitute n be equal to 2, we get the value 6. Okay, and so on and so forth. So domain is the input, and 3, 6, 9, 12, and 15, we call them range. It's the set of y values. Domain is the set of x values. Range is the set of y values. Okay, the range gives the terms of the sequence. So this is a finite sequence having the rule a sub n is 3n. Okay, when we substitute n be equal to 1, okay, the first term is 3. Okay, we have the output 3. If n is 2, the output is 6. Okay, so this is now the general rule, 3n. This is finite sequence. When we say finite, okay, it's countable. Okay, you can find the last term. You can list all the terms, where a sub n represents the n term of the sequence. Okay, given this general rule, 2n plus 3, write the first 5 terms of the sequence. Okay, so let's have Mitzi. Okay, Mitzi, what is the first term? Okay, very good. The answer is 5. How about the second term? How about Celine? What is your answer? Okay, the answer is 7. That's the second term. How about the third term? Yes. Wants to answer? Yes. Eugene. Okay, the third term is 9. How about the fourth term? Okay, the answer is 11. And the fifth term, how about Gob? Okay, the answer is 13. Can you follow? Is that clear? Okay, very good. So let's have another example. Okay, write the first 5 terms of the sequence a sub n equals n over n plus 1. Okay, what is the first term? Okay, what is your answer? How about Marisol? The answer is 1/2. Correct. The second term. The answer is, how about Gwine? The answer is 2/3. Correct. How about the third term? Yes, Beron, what is your answer? 3/4. Very good. How about the fourth term? Yes, Leilani? Correct. The answer is 4/5. And the fifth term is 5/6. Okay. Any question? Is that clear? Okay. Are we clear how to find the first 5 terms given the general rule? No more questions? Okay, so let's have arithmetic sequences and series. So, what do we mean by arithmetic sequence and series? How do we know if the given sequence is an arithmetic? By the way, arithmetic sequence is a special sequence. Okay, we're going to identify. How are we going to identify if the given sequence is an arithmetic? Okay, so let's differentiate first what is sequences and series. Okay, so what have you noticed with the examples in our previous examples? Okay, so when we say sequence, okay, these are set of numbers, okay, listed with commas. Okay, how about series? Okay, indicated sum. It's the sum of the sequences. Okay, it's the summation of the given sequence. Okay, the given sequence is 3, 8, 13, 18. So when we need to find the series, we need to find the sum of the given sequence. Okay, is that clear? Okay, next. So how do we know if the given sequence is an arithmetic? Okay, please read. Yes, Hector. An arithmetic sequence is defined as a sequence in which there is a common difference between consecutive terms. You're going to find the difference, okay, of each term. If they have common, okay, difference, okay, for that sequence, it's an arithmetic. Okay, so let's try to identify the following sequences if they are arithmetic. If the given example is an arithmetic, identify the common difference. Okay, how are we going to identify the common difference? Yes, Rain. Okay, we're going to subtract the second term by the first term. Okay, the third term minus the second term, and so on and so forth. Okay, so let's try number 1. Let's try number 1. Yes, Mitzi? Is it an arithmetic given this? What is the common difference? Do they have a common difference? Negative 1 plus 3. The answer is 2. 1 plus 1 is 2. So how are we going to find it? Negative 1 minus negative 3. So negative 1 plus 3 becomes negative 1 plus 3. The answer is 2. 1 minus negative 1, so it becomes positive. 1 plus 1, it's 2. So it's an example of arithmetic, correct, Mitzi? And the common difference is 2. Next, how about number 2? Yes, 1. Okay, 14 minus 15.5. What is the answer? 12.5 minus 14. Is it an arithmetic? Okay, the correct answer is yes. And what is the common difference? It's negative 1.5. So 14 minus 15.5, it's negative 1.5. 12.5 minus 14, it's negative 1.5. Okay, how about this one? Yes, how about Celine? 80 minus 84, the answer is negative 4. 74 minus 80, the answer is negative 6. Is it an arithmetic? The answer is very good, Celine. The answer is no. Is that clear? So the first thing you have to do, you need to identify if it's an arithmetic or not. Okay? Before you apply the formula for arithmetic. The general formula for arithmetic sequence. Okay. Are we clear? So with that, okay, I'll give you an activity, a group activity. You're going to answer even numbers. Okay, you group yourselves into 3. you're going to answer this activity. Find the next 4 terms of each arithmetic sequence. Only even numbers, 16, 18, 20, 22. Okay? And then 24, 26, 28, 30. Find the first 5 terms of each arithmetic sequence described. After that, we're going to check. Then we're going to proceed to we're going to continue our lesson about arithmetic sequence. Okay? So that's all for today. So the add numbers, that will be your assignment. That's all for today. Goodbye, class.